Okay, guys, and into the second part of 14.1. In the first video, we talked about these. I believe there were 8 new identities that we learned right here. 3 reciprocals, 2 tangent and cotangent, and then we also did the 3 Pythagorean identities. And we talked about variations on each of the Pythagoreans. So now let's talk about what this might be good for. This second section right here we're calling simplifying trigonometric expressions. And if you guys remember way back to Algebra 1, but also earlier in the year here in Algebra 2, simplifying expressions was usually something you had to learn how to do before you could solve equations. But even though we learned it first, simplifying expressions is usually, I guess this is just my opinion, but many people have told me the same thing, harder than solving equations. Because with solving equations, you know what it is you can do and what you can't do, and you usually know when you're done. Simplifying expressions is a little bit more vague. So I wrote down really only 2 hints for simplifying. And guys, I'm saying these are hints and not rules because these often work, but not always. And I debated going back and forth on the order of these 2, and I decided to leave it right here, but sometimes I change my mind and I like hint number 2 before number 1. So one hint right here for simplifying trig expressions is to express everything in terms of sine and or cosine. Okay, now real quickly, if you wanted to jot all this down yet again, what we've learned here, guys, is that all of the other trig ratios, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. The other 4 can all be expressed in terms of sine and cosine. Tangent of theta can be written as sine of theta over cosine of theta. Cosecant of theta is 1 over sine of theta. Secant of theta is 1 over the cosine of theta. And cotangent is the reciprocal of tangent. So that's going to be the cosine of theta divided by the sine of theta. So these are ways that you can take any of the 4 uglier trig ratios and express them all in terms of the 2 nice basic ones of sine and cosine. That's a strategy that very often, not always, but very often helps. And a second one, always a good idea anytime we're simplifying something in math, factor your expressions. Using really the same rules that you've learned for factoring numbers and algebraic expressions, they can just be harder to spot in a case like this. So let's take a look at our first expression, and I should have written the simple word simplify. There you go. We're going to try to rewrite this expression here a slightly different way. Okay, guys, we've got the secant of theta times the tangent squared of theta plus secant of theta. Well, the first thing I think I probably notice, and I would want you guys to notice also, is that this expression has 2 terms. This is one big term right here, and here's a second term. Terms, you guys, are separated by plus signs and minus signs. Secant of theta being multiplied by tangent squared of theta, that's just one term. So when we notice this is a binomial expression, the first thing I want to do is try to see if those 2 terms have a common factor that we can pull out in front. And they do. I see a secant theta here and a secant theta here. So we're going to pull out the GCF, the greatest common factor of these 2 terms, secant theta, bring it out in front, and then start a set of parentheses. I'm hoping this looks familiar, guys. What we're doing is reverse distributing. Okay, this is what we do in factoring. So we bring out the secant of theta, and then what's left from the first term? Secant theta, tangent squared of theta, divided by the secant theta we just pulled out is just going to leave you with tangent squared of theta. And then plus, people goof this up a lot. Remember, this is division. Secant of theta divided by the secant of theta we just pulled out leaves you with a 1, not a 0. A good number of people are just going to say, nope, the secant of theta is gone, so that's what I'm left with, and that's not the way this works, guys. I'll tell you again, it's division. So secant of theta divided by the secant of theta you pulled out leaves you with a 1. Now, you really can't do anything with secant of theta. We could rewrite that not equals. We could rewrite that as 1 over cosine of theta, but I don't really think there's a point to that. But now what I notice here, guys, is a trig ratio is being squared and then added to a 1. Now, you guys need to get used to seeing that. When you see that, I'm going to go back to my Pythagorean trig identities, which were located right here, all three of which you'll notice contain the number 1, and they all have a trig ratio squared. So what we had written down on our paper that we were looking for was tangent squared of theta plus 1. Well, let me look right here, guys. There I see it. 1 plus tangent squared of theta. And of course, remember, the order of addition does not matter. 1 plus tangent squared of theta can be replaced by secant squared of theta. So everything in the parentheses now becomes secant squared of theta. And now we try to simplify this if we can. Secant of theta times secant squared of theta. Well, that's 3 secants right there. This is now going to be secant cubed of the same angle theta, and there's nothing else you can do to simplify that, guys. That would be our answer. The one thing I will tell you that you could do equivalently here is that secant is the reciprocal of cosine. So you could write this as 1 over cosine cubed of theta, but I'm not going to say that one of those forms is better than the other. I'd give you full credit for either one of those there, guys. Secant cubed of theta or 1 over cosine cubed of theta. Okay, so that's our first real simplification. Unfortunately, guys, there's no way to test that. There's no way to find out we're right. You could maybe do something in your calculator, but it doesn't really work out that well. Let's look at another one. This one's simpler up front. Cotangent of x times secant of x. Now, factoring was the first thing I did on the last problem, because in the last problem we had a binomial expression. But this expression is really just one term. Remember, multiplication, which is what we have right here, does not separate terms. That's only addition or subtraction. Okay, so with that in mind, then, everybody, you can't factor right here because this is a monomial expression. So let me go to that other hint that I gave. Change everything into sines and cosines. So cotangent of x, I'm using x and not theta here, but that's fine. Okay, where was I? Cotangent of x or theta, I'm going to use this identity right here, and I'm going to turn cotangent into cosine over sine. So here you go. Cotangent of any angle is going to be cosine of the same angle divided by the sine of the same angle. And then we're going to multiply that by secant of x, and secant is the reciprocal of, or 1 over, the cosine of the same angle. And now what do we notice? Oh, we're multiplying two fractions together, and the cosine of x is in the numerator of the first fraction and the denominator of the second. They cancel each other out, just leaving us with 1 over sine of x. And that right there, guys, is the definition of the cosecant of x. Now, just like on the last problem, I'd actually give full credit for either one of those answers right there and tell you both of those are fine. I actually feel like this one is probably the better answer, but some people feel that 1 over sine is easier to understand or simpler than cosecant. And then, it's not exactly cut and dry right there what the fully simplified version of an expression is. It's not like solving an equation where we know where to stop. Okay, not too shabby. Let's look at this third one right here. Secant of x times sine of x plus sine of x all over 1 plus secant of x. Now, what I'm hoping everybody knows is that as tempting as it is, you cannot simply do this, crossing out the secant of x on the top and bottom. As we talked about way back in chapter, 8, everybody, when we were simplifying rational expressions, meaning fractions, you can't cancel until you have factored first. So actually, saying the F word right there, guys, makes me realize how I'm going to proceed. In my numerator, I have a binomial, secant of x, sine of x, plus sine of x. I'm going to pull out the common factor they both share, which is sine of x. And then in a set of parentheses, secant of x is left over, and then plus, there was a sine of x, we pulled out sine of x, that's going to be a 1 right there. And on the bottom then, you can't factor anything out of 1 plus secant of x, so that just stays 1 plus the secant of x. But what do I notice here, guys? A binomial expression in the numerator and this binomial in the denominator, those are identical. Remember that the order of addition doesn't matter. So that entire factor right there cancels itself out, and we're simply left with the sine of whatever angle x was. And that's our answer here for part C. So guys, some of these simplification problems can be really, really difficult, and some of them are pretty straightforward and really not that tough. We're going to try to focus on some of the easier ones with you guys this year, but next year, if you take pre-calculus, you're going to revisit this concept of simplifying trigonometric expressions, and it can get a good bit harder. Now, what we're doing next looks like a new style of problem. This is actually probably easier than what we just did. Verifying an identity. Now remember that verify is kind of like the P word from geometry, guys. It's kind of like the word prove. But relax, it's not as formal as a geometric proof. They're actually telling you what the answer here is. In the last three problems, maybe they just give you an expression like this and the directions say simplify. Well, now they're telling you basically to do the same thing, but this is what you should end up with. So there's two ways you can go on a verification problem. You can either manipulate the left side to make it turn into the right side, or going the other direction with that, you could flip that around and manipulate the right side and try to make it equal the left side. And knowing which way to go, well, let me tell you, both of them will work. But this is just kind of an instinctual thing that I think you guys are going to pick up after a while right here with a little bit of practice. Now, what I'm noticing right here, guys, is that we have a cotangent squared on the left over cosecant of x. Okay, so those are two monomials being divided by each other, and then a binomial expression over there on the right. So what I think I'm going to do here with this one, guys, I can really see it either way. I'm going to go ahead, I think, and I'm going to manipulate the left side and try to make it look like the right, because I see a little trick here that I haven't talked with you guys about yet in this video, and I want to talk about how to do that right now. What I notice is that I've got a cotangent of x squared, all by itself, not a binomial expression. There's not a +1 or a -1. So anytime you see a trig ratio squared, I'm going to go back a few slides here, guys, to the page on Pythagorean trigonometric identities, which is right here. And cosecant squared of theta, I see right here, could be rewritten as 1 plus cotangent squared. And I think that's what we had in this problem. Yeah, cotangent squared of theta could be rewritten, we just said, as 1 plus the cosecant squared of that same angle, x, all over cosecant of x. Okay, so that's what we have right over here. And now we're going to take advantage of a trick that's going to be relatively useful for you guys moving forward. If you think back to, I don't know, something like 6th grade math, if I ever asked you guys to add two fractions together, like 5 over 8 plus 1 over 8, they have a common denominator. You'd add together the 5 plus 1, but you'd leave the denominators the same. So you'd end up with 6 over 8, and then you'd simplify that to make 3/4. What I want to talk about, though, is the idea that you could actually go backwards from this step right here and make this 5 over 8, which is this fraction, and then make this fraction here 1 over 8 and add those two together. So the basic property, guys, is that if you have a sum, a plus b, divided by a monomial base, you can break that up doing it this way. A divided by c now gets added to this fraction right here, b divided by c. Now, I don't know that that's a formula or a property that we ever explicitly wrote down in here this year, but it works on the same principle you've been using for years on adding fractions, just takes it backwards. So when you notice that you have a binomial divided by a monomial, that's how I'm going to handle this. My first fraction is going to be this, 1 over the cosecant of x, and then plus the second fraction is going to be this, cosecant squared of x divided by cosecant of x. Now again, I'm not writing the right side, guys, because I really just want this same thing to come straight down here and here. I'm trying to turn the left side into this expression. Okay, so where does that get us right here, guys? That cotangent was equal to, now give me just a second here, everybody, as I'm looking at something, cotangent, and I think I made a mistake right here, and I think I got to fix it real quick. cotangent squared of x is what I had by itself there. If I go here, sorry guys, cotangent is with the plus 1. So if I had brought this 1 to the other side, this should have become cotangent, no. It should have become cotangent squared of theta is equal to cosecant squared of theta minus 1. That I was thinking I was looking at cosecant there. Sorry. So that's what I should have turned the cotangent squared into. Cosecant squared minus 1. So that's going to change what I did right here. Luckily, it's not going to change what happens next. But this should have been, cosecant squared of x minus 1. Okay, so what's that going to do right here, guys? This then should have been, the cosecant squared of x over x, and then minus 1 over cosecant of x. Sorry about that, guys. And now, let's try to simplify each one of these fractions. Now, the first one, cosecant squared of x divided by cosecant of x. Anything squared divided by itself, like for example n squared over n, remember this is n to the first, you just make this n and then you subtract those exponents. 2 minus 1 is 1. Cosecant squared of x divided by cosecant of x is just cosecant of x. And then minus. Now we've never actually written this down before, guys, but what we have right here is 1 over cosecant of x. It's 1 over one of the reciprocal identities. And it really makes no mathematical sense at all to have a reciprocal trig ratio like cosecant or secant or cotangent on the bottom of a fraction. A cosecant in the bottom simply becomes a sine of x in the numerator. Okay, so if this were a secant, we would have made this a cosine. If this were a cotangent, we would have made this a tangent up in the numerator. And now I want you guys to realize that in 1, 2, 3 steps here, we just turned the left side into the right side. That equals cosecant of x minus the sine of x. And that is exactly what we were trying to, wait a minute, what's the word? Trying to verify. That you can algebraically manipulate one side of this equation according to the identities and properties that we talked about, and in a few steps, magically turn it into the right side. So that's how you verify a trigonometric identity. You're using all those properties that we just talked about, you're manipulating some things, and you're turning one side into the other. Now here's the second and last problem that I wanted to do with you guys. Sine of x over 1 minus cosine of x is equal to 1 plus cosine of x all over sine of x. And this one, I don't necessarily think is as quick and easy to see as what we're doing in the last one. But we'll try to get through this one, and hopefully I won't screw this one up the way I did on the last one here, guys. So, all right, let me move everything over just a little bit. Now, at first glance, there doesn't look like there's a whole lot of things you can do here, but I'm going to teach you guys a little trick here that what I have in my second numerator here, guys, is 1 plus cosine of x. This trick is going to come in handy. I am going to multiply, and you'll see why in a minute, both the top and the bottom of that expression by the conjugate of this binomial. And if you remember conjugates, it means they have the same first term. So that would be a 1, but an opposite second term. 1 minus the cosine of x. And I'm going to multiply 1 minus cosine of x on both the top and the bottom of the right side. By the way, if you couldn't tell, I'm going to do this one the other direction. I'm going to leave the left side alone, and I'm going to work on the right side. Now, on the right side, we're going to multiply 1 plus cosine of x times 1 minus cosine of x. And how are we going to do that? Binomial times binomial, we use FOIL. First product is 1 times 1, which is just 1. But here's the cool thing, guys. The outer product, 1 times minus cosine of x, is negative cosine of x. You don't need to write this down. You'll see why in just a second. The inner product right here is cosine of x times 1. So that's plus 1 cosine of x. And then the last product, positive cosine of x times a negative cosine of x, is negative cosine squared of x. And what I'm hoping you guys recognized and maybe remember now, anytime you multiply, you FOIL together two conjugates, the outer product and the inner product are always just going to be opposites of one another, so they're going to cancel each other out. Now the good news is, in the denominator here, the sine of x times the 1 minus cosine of x I could distribute, but 1 minus cosine of x is what I want in the denominator on the left-hand side. So I'm going to leave the right denominator in factored form. Sine of x times 1 minus cosine of x, and you'll see why in a minute. Okay, then my numerator right there, guys, just becomes 1 minus cosine squared of x all over sine of x times 1 minus cosine of x. And right about now, something cool happens. That numerator, which was just 1 plus cosine of x, has now turned into a binomial where one of the two terms is 1 and the other one is a trig ratio squared. And again, that makes me think about Pythagorean trig identities. 1 minus cosine squared of x, I think we have written down somewhere, guys, and I think it's right here. There it is. Whoop, 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 I had it. 1 minus cosine squared of theta can be replaced by sine squared of theta. You want to make sure you get the order right, but yeah, that's right. 1 minus cosine squared becomes sine squared. So you got to read those identities in some different ways. So my numerator on the right side becomes sine squared of x all over now sine of x times 1 minus cosine of x. And just like what happened on the last problem, we've got a sine squared on top and a sine of x on bottom. That means that this sine of x cancels with one of the sines of x on the top, but not both of them, leaving us with just one sine of x factor all over 1 minus the cosine of x. And that, ladies and gentlemen, is exactly what we wanted this right side to now become to match the left side. Sine of x over 1 minus cosine of x. And that's the verification of this trigonometric identity that we were looking for. So we did two of those examples here together. That's certainly not everything, you guys. That's certainly not all of it. And I think if I spent another hour here showing you problems, that still wouldn't be all of it. But hopefully that gives you some sense for how to do problems like this and gives you enough confidence then you guys can dive into the homework here on 14.1 and then ask some questions after that when you get stuck. So guys, dive into it. Remember that you are not going to have all of these trigonometric identities memorized for a long time, maybe not ever, so you need to have your notes open right next to you while you're working on this homework and start looking for things that sometimes pop up and then replacing them with something simpler that they're equal to. And that's about as general as I can make it. So dive into that 14.1 homework. Good luck, everybody, and let us know when you guys have questions.